Hello everyone. In this lesson, we'll start working with different game levels. Let's prepare the scene for creating several levels, create prefabs, and write scripts for switching between scenes. The levels will differ only in the gate location and properties and the coin location. Nothing else changes, which means we can do it all using prefabs. Let's start by combining all the objects that repeat from level to level into one object and one prefab. The visuals are universal for the whole game. The shadows fall from the same side, and the road is always the same. Because of this, we'll take the light source, the road, and all these managers, and put them all in one object, which is universal for all the scenes. I'm going to create a new object by clicking Create, Empty, and call it Common. Let's place it at 0 coordinates to keep things neat. We'll also create an object and call it Level. This is for what's different on different levels. We'll put the gates and coins in it. So I'll put all the coins and all the gates into this level here. By the way, you can temporarily hide it like this to check whether you forgot anything. This gate and these coins also go here. And now, Directional Light, Ground, Coin Manager, Event System, all these canvases, and Game Manager all go to Common. They're the same at every level. The player and the camera are basically the same at every level, too, but let's keep them separate. Also, for the player and the camera, we'll make a prefab as well, so that if they change on one level, they change everywhere. So the key problem here is that when you have 50 levels, 50 scenes, you need to synchronize them so that if you change something for the player in one scene, it changes everywhere. Because of this, we'll use prefabs. To avoid creating separate prefabs, you can put the camera in the player. Like that. But there's a problem. If the player rotates, the camera will rotate too. We don't need that. So in the camera script, the camera is in the center. Let's make the camera cease to be the child object. I'll add the start method here. I'll just write transform.parent equals null. Transform.parent is the parent object. You can view it, assign an object, or write null so that there's no parent object. Save the script. The finish object is always the same too, except we'll move it to different places on the road so that some levels are longer. We'll make the most of all these objects prefabs. That is, we drag Common to the prefabs folder. Do the same with the player and the finish object. A level is an object that's universal in every scene. It's just gates and coins. They can be arranged in any way. We won't make it a prefab. By the way, I made a clumsy mistake here. I created a level and attached everything to it right away, but then it turned out that its center is here, far away. Not at 0 coordinates. It won't be very convenient to work with this later. To see what the problem is, look at the position of this gate. I want it to stand on the floor. If I lift it up a little like that, it would be nice to simply set y to 0, and the gate will be in the right place. But since the parent object is positioned wrong, and the gate is relative to it, the gate is at 0 relative to this object, which is weird. Let's fix that. We need to disconnect them all again. And then put the level object at 0 coordinates. This is what it looks like now. And all our levels will look like this. The only thing that will change is the content. To make it clearer what level we're at, I want to write level 1, level 2, and so on here at the top. In the common object, there's this canvas where the coin is. Let's rename it so it's easier to find. Let's call it Canvas in Game. It's in the game. It's just the main canvas that's displayed in the game. In it, I'll create a new text. UI, text. Let's call it Level. And fix it at the very top. I press and hold Shift-Alt and click here. Let's write something in it right now, say level 0 or level X. This way, we can immediately see the changes. Pick a color, let it be black for now. And bold. In the script, we'll write how this word should change. We have the Game Manager script. Let's open it and add a link to the text. You probably remember what the text is called. By the way, here's an interesting point. I'm typing Text Mesh Pro, but Visual Studio doesn't prompt it for some reason. It's strange, but this button with a green plus sign was inactive. Remember what it means. If it's active, it means you can use the class names that aren't imported here right now. You see, we have several libraries imported. And we can use functions from there. But Text Mesh Pro is in the TM Pro namespace. If the plus button isn't pressed, the external namespace that isn't used in this file isn't displayed. If it's pressed, they're displayed. If we select it, this namespace will automatically be added here. In short, make sure that the green plus is pressed. Otherwise, you'll just have to remember what namespace you need and type using manually, which takes unnecessary time. So, we created a new field level text. At the start, when the game starts, we need to write something there. Actually, we need to write the name of the scene. We take the text and change its properties, text equals. How do I find out the name of this scene? We're working in a certain scene right now. It's called Level 1. It's in the Scenes folder, together with the old test ones. How do we find out its name through the script? How do we display it? There is a separate class for this, called the Scene Manager. Again, the green plus isn't pressed. Here's the Scene Manager. The namespace will also be added. Then we put a period here. There are different methods for managing scenes and finding out the current scene. Get active scene. This way, we'll get the current scene. We're interested in its name, not in the scene itself. Type a period and the word name. That's the name of the scene. It will be in the text. Let's take a look. Click play. That's written correctly, Level 1. What do we need to do now? If we change something in the common file, we'll be changing something here all the time. The development process is still underway. We added this text, and we need to click Overrides, Apply All every time. That's it, the change is applied. So now let's save this scene and see how to create the next one. Just go here in the Scenes window. There are still old test scenes here. If you have something like that, you can delete it. Only keep what you need so that nothing distracts you. You can copy this scene. Just press Ctrl D, and it's automatically called Level 2. Not bad. They're exactly the same now, but we can go to the Level 2 scene and fix something here. To save time, let's not design anything interesting here. Just make the levels different in some way. Do it. Now we have 2 scenes. When you switch between scenes, press Save to save the changes. Here are 2 slightly different scenes with different names. Let's copy a couple more scenes. We'll have 4 of them. You can make some changes to each of them. What do we do next? These scenes still need to be added to the build. That is, if we leave everything as it is now and if we don't launch it in Unity but create an assembly for some platform, only the scene that's currently active on the screen will get there. We want all these scenes to be included, so we go to File, Build Settings. Here's a list of all the game scenes. You can just grab them like that and move everything here. There's a deleted scene here, and you can remove it like this. The scene order is also important. The scenes must be in the right order. We'll close this window now. Now, when the player finishes level 1. The player reaches the finish line. They can either reach the finish line or stumble over these objects and never get there. But in our game, even if they die before reaching the finish line, they still go to the next level. Because, otherwise, the levels will be just impossible to pass, so we made it impossible to lose. The player always goes to the next level. So, where do we start? Let's open Game Manager. Here in Common, we have Game Manager. Open it and create a method to move to the next level. Let's call it Next Level. But we'll move to the next level only when the user presses the button. That is, they either won or lost, but a window should open that says Game Over, and there should be a Next button. So we need the method public void show finish window, for example. Then we add a link to this object, this window. Game object finish window. And this method activates it, that is, set active true. We'll call this method in two situations, when a player dies and when they reach the finish line and dance. Now for the next level. What happens here? We need to call Scene Manager again and call the Load Scene method. That's how we load a scene. In the parentheses, you need to enter the scene index. That is, if we're in the second scene now and we want to load the next scene, it's the third one. The number of the current scene plus 1. First, we need to find out the number of the current scene. We call Scene Manager again. getActiveScene.buildIndex. This is the current build index. We just added scenes here, and you see they have these numbers. These numbers mean the order of the scenes. The first scene index is 0, and the second scene index is 1. So write buildIndex plus 1. This is how we load the next scene. It's also a good idea to make sure that we haven't run out of scenes yet, right? Because if there are no more scenes, this will cause an error. We need to prevent that somehow. In the beginning, let's calculate the next scene number and save it to a variable. For example, in next. This is what I'll name it. Then we need to check whether the next number is fewer than the total number of scenes. How do we find out? Scene Manager. Here it's Scene Count and Build Settings. That's what it's called. So if the next scene number is fewer than the total number of scenes, everything is fine, and we can load the scene. The scene with the next index. What's left to do is to create the window with the button to go to the next level. That's simple. We'll create it in a new canvas. Create a new UI canvas. Let's call it End. Here you can make a window. For example, it's an image of a particular size. This is the play button, and it's getting in the way now. You can just lift it up like that for now. It doesn't work. But you can increase sort order in the canvas settings. It's the order of drawing the canvases. The higher it is, the higher it's drawn. But in fact, these windows will be displayed at different times, so they will never block each other. So this is the window background. You can add a background image, but the most important thing is to have some text here. For example, finish. Put it on top, press Shift plus Alt, and click here. We're creating it in a kind of programmer style today. We also need a button that says Next. It should probably be green. Great. Now change the names button next. Canvas and all good here. This canvas is necessary on all game levels, so drag it to common. We want to turn it on and off in Game Manager. That's it. We apply these changes to the prefab. You also need to assign an action to this button. That is, the event that's triggered when the button is clicked. Click the plus sign. Drag Game Manager here and select Game Manager. Next level. Click Overrides, apply all again. At the start, this window should be hidden. Of course you can write it in the script, but let's just hide it manually. Because I hid it, every time this object is changed, you need to click Apply All. There's also this method in Game Manager. Show Finish Window, we need to call it from somewhere. As I said, there are two options: the player wins or loses. First, if they win, here's the finish trigger. Let's do it this way. We need to find the Game Manager object in the scene. We can do this using Find Objective Type. Call Show Finish Window. This is the first option. Actually, we can call the same line from Player Modifier. Here the player dies. At this point, they just disappear and that's it, the game freezes. But we can go to Game Manager and ask it to show this window so that the game can be continued on the next level. Save everything and check it. By the way, we don't destroy the gate when we run through it. We need to call the destroy method here as well. So the character runs and grows smaller, losing weight every time. They run through the next curb but still don't reach the finish line. However, the finish window opens. We can click Next, and the next level loads. The coins are placed somewhat differently, and it says Level 2. Click Play again and let's run and check again. Maybe if they're tall enough, they can reach the finish line. The script allows the character to get even smaller than 0, but that's okay. I think it looks pretty funny. Click Next and go to Level 3. Everything is fine here. But pay attention to the fact that the coin counter is reset every time. And we haven't implemented the system where the player can buy height and width for the character. Yes, those buttons in the menu. We'll talk about that later. For now, these buttons don't do anything, and I still think it's a bit odd that the gate remains in place when the character runs through it. It'll look more interesting and dynamic if the gate gets destroyed. Here's the on-trigger-enter method. We made sure that it was the player that got into the trigger, and here the gate can be destroyed at the end. Just type destroy. Game object. Great! The gate disappears. It seems simpler and clearer now. Let's summarize. To get the scenes into the final build, add them to the build settings. All objects that don't change from level to level can be placed in one prefab.